Welcome to Future Dr. NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 11, Dual Nature of Radiation. Let's move to first question, and this session is not a problem solving session, problem questionnaire session. That is, 7 questions will be spread in this session, and next session only we will solve the solution for this question. Let's move to question number 1. The work function of a photosensitive material is 4.0 eV. This longest wavelength of light that can cause photon emission from the substance is dash, approximately dash. A option 3100 nm nanometer, B option 966 nanometer, C option 31 nanometer, D option 310 nanometer. That is, you should know the formula for work function with respect to that energy emitted or energy absorbed. By knowing the formula, you will solve the solution for this question. Let's move to question number 2. Photons with energy 6 eV are incident on a cathode C in a photoelectric cell. The maximum energy of emitted photoelectrons is 3 eV. When photons of energy 7 eV is incident on C, no photoelectrons will reach the anode A. If the stopping potential of A relative to C is dash, option A plus 3 volts, B option plus 4 volts, C option minus 1 volt, last option minus 3 volt. That is, here you should know the formula for stopping potential with respect to that energy and work function formula. By knowing the formula, you will be able to solve the solution. Let's move to question number 3. Light of wavelength 600 nanometer is incident on a metal with work function 2.28 eV. The de Broglie wavelength of the emitted electron is dash. A option less than 2.8 into 10 power minus 10 meter. B option less than 2.8 into 10 power minus 9 meter. C option greater than or equal to 2.8 into 10 power minus 9 meter. D option less than or equal to 2.8 into 10 power minus 12 meter. Here you should know the formula for de Broglie wavelength. De Broglie wavelength, you should know. From that, you will solve this solution. Let's move to question number 4. When the energy of the incident radiation is increased by 20%, the kinetic energy of the photoelectrons emitted from a metal surface increased from 0.5 eV to 0.8 eV. The work function of the metal is dash. A option 0.65 eV, B option 1.0 eV, C option 1.3 eV, last option 1.5 eV. Here also you should know the formula for work function in terms of potential and kinetic energy. By knowing the formula, that is photoelectric equation formula, you will solve this question. Let's move to question number 5. Light of 2 different frequencies whose photons have energies 1 eV and 2.5 eV illuminate on a metal surface whose work function is 0.5 eV. Ratio of maximum speeds of emitted electrons will be dash. A option 1:2, B option 1:1, C option 1:5. Last option 1:4. Here you should know the relation between work function, maximum speed. Then by knowing the formula with the frequency, you will solve this solution. Let's move to question number 6. The number of photoelectrons emitted for light of a frequency mu higher than the threshold frequency mu naught is proportional to dash. Option A mu minus mu naught. B option threshold frequency mu naught. C option intensity of light. D option frequency of light mu. Here you should know the relation between number of photoelectrons emitted with respect to frequency and threshold frequency. By knowing the relationship, you can solve this solution. Let's move to last question. Question number 7. Einstein's work on photoelectric effect gives support to dash. A, E equal to mc square. B, E equal to h nu. C, h nu by half mv. D option, E equal to h by lambda. Here you should know the photoelectric effect, that formula. By knowing the formula, you will solve this solution. Okay, thank you, students. So in next session, you will solve how to find the solution for this question. Thank you.